Unit 6, Section 4, Properties of Similarity. This is our last section of this unit. We're going to talk about some of the applications, especially with triangles and parallel lines and things we're pretty familiar with, and what properties of similarity could mean. And so we have some different theorems we're going to look at. And this first one is just a review. It's the triangle midsegment theorem. And that's when we drew this midsegment, so we know that D is a midpoint on that side, and we also know that B is a midpoint. So that was kind of what was key about how we constructed that. And then we also knew that BD was parallel to AE. And then that, because of that, that made AB and BC equal and CD and DE equal. And like this theorem states, 1/2 of the length of AE was equal just to the length of BD. So that's to say BD is half the size of AE. So that's the review. On to a couple new theorems. The first one is triangle proportionality theorem. And so the first thing to notice about this theorem is that N and J on this triangle, those are not midpoints. So I'm actually going to write that in just so it's clear. Whoops. So that's when we have some sort of other line somewhere in that triangle that they're still parallel, but those aren't midpoints. And so the theorem says if a line is parallel to one side of a triangle and intersects the other two sides, like NJ does in this triangle, then it divides the sides into segments of proportional length. So that means we can set up a proportion to solve for a missing side length. So that's to say that NY and NB, let's see, maybe I'll do the smaller one in blue. The proportion of that is related to the proportion of these two. It's not saying they're equal. So I'm going to erase that because I don't want you to think they're equal, but I'm just trying to show you what sides we're talking about. So if I was going to set that up, I would say NY over NB. So the big one over the small one on the left side, the proportion of that is equal to the big one over the small one for that proportion on the right side. So once again, I'm not saying any of those particular ones are equal. I'm just saying that they're proportional. And so the converse says if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then we'll know that those two lines are parallel. So it's saying if I know that NY over NB equals JY over JK, then I could prove that those two lines are parallel there at the bottom. So that's pretty key when we're thinking about these side lengths and knowing what's proportional and what's not. This one, proportional parts of parallel lines, it says that if three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. This is essentially the same thing as what we just did with that triangle, but it's just saying there's more lines in there. And so some of the proportions I could set up, I could say EF, so I'm going to stay on the top, and then I could say EF over, let's say, DE, that other piece, is going to be equal to the proportion of BC over AB. So I always stay, for this first one, I stayed on this side, and for this one, I stayed on this side. And it's saying if I cut them into the same pieces with parallel lines, I can get some proportions. Another proportion I could have written was EF over BC. Now that's different in that we're picking one from each side, but then I could say that that's equal to DE over, you guessed it, AB. So that's different in saying we'll do, let's see, EF and BC are the ones right in here. So it's saying this side length over that side length will be equal to that side length over that side length. So it's all about how those parallel lines cut things into proportional pieces. Now, maybe my color coding didn't really help, but I want you to look at those proportions and believe that they might be true just because those lines are parallel. The last thing is congruent parts of parallel lines. So here we have a ton of parallel lines. I'm going to make this a little bigger so I can draw on it. Here I'm saying that this, I'm going to do that in black actually. This is parallel to this. All of these lines are parallel. And then they cut off congruent segments of one transversal. So let's say I'll start with the transversal on the left here. So all of these little pieces are going to be congruent. So they're all a congruent distance apart. So they're these lines that are all parallel and all the same distance apart. Then they cut off congruent segments on every transversal. So this transversal line we have here on the right, then you know this piece is equal to this piece is equal to that piece, and so on. So I could draw a line any way. I could have drawn a line like, let's see, I could have even drawn like a really bizarre line like that, and I could have still said that that piece is equal to that piece, is equal to that piece, which is equal to that piece, which is equal to that piece. I can't say, and I really should have drawn 3 little tick marks because I don't want you to confuse that with the other one. So I'm not saying that those little pieces are all the same in relation to the other lines, but within one line, if you would, however you draw that line, how it's cut into pieces, they're all going to be congruent. So those are some of the main properties and theorems we have with, it all has to do with parallel lines and proportional side lengths and whatnot. So the next video will have some examples that will hopefully make this a little more clear. So stay tuned for video 2.